Welcome to Historia. Imagine a world where the sunrise and sunset were the only clocks, where the rhythm of life was dictated by the shadow of a stone. Today we travel through the ages to uncover how humanity learned to measure the invisible flow of moments. From the first markings on stone to the invisible ticks of atoms, the story of time is the story of civilization itself. Join us as we follow the relentless quest to capture time, a journey that reshapes how we live, work, and understand the universe. Chapter 1. From Sun and Water to Stone. Long before mechanical gears, early societies turned to the sky and flowing water to mark the passage of day and night. In ancient Egypt, towering obelisks acted as giant sundials, their shadows indicating the hours as the sun traced its arc across the heavens. Simultaneously, the Mesopotamians developed water clocks, or clepsydras, where water dripped at a steady rate from a vessel into another, providing a reliable measure when clouds hid the sun. These devices allowed priests to schedule rituals and farmers to plan irrigation, embedding timekeeping into the fabric of daily life. The concept of dividing the day into 12 parts emerged during this period, laying the groundwork for later calendars. The Babylonian scholars refined the division of time, adopting a sexagesimal, base 60, system that still influences how we count minutes and seconds. Their astronomers recorded celestial events on clay tablets, noting the length of the solar year and the cycles of the moon with remarkable precision. By the 4th millennium BCE, they were using water clocks calibrated to the length of a night, enabling them to track the passage of hours even after sunset. This mathematical approach to time spread throughout the Near East, influencing Greek and later Roman practices. The legacy of these early innovations is evident in the very numbers we use to measure time today. Chapter 2. Greek and Roman calendars. Greek astronomers such as Hipparchus introduced more accurate astronomical observations, allowing the creation of calendars that aligned civil life with the solar year. They devised the 365-day year with an extra intercalary month inserted every few years to keep festivals in season. The Greeks also improved water clocks, adding gears that produced audible ticks, a precursor to later mechanical devices. Their work on the Metonic cycle, a 19-year period after which lunar phases repeat on the same dates, became a cornerstone for later calendar reforms. When Julius Caesar assumed power, the Roman calendar had drifted far from the solar year, causing confusion in agricultural and religious scheduling. In 45 BCE, Caesar, advised by the Alexandrian astronomer Sosigenes, introduced the Julian calendar, fixing the year at 365.25 days by adding a leap day every 4th year. This reform standardized the length of months and aligned civic duties with the seasons for the first time across the empire. The Julian calendar would dominate Europe for more than a millennium, its influence persisting in the modern Gregorian reform. Chapter 3. Mechanical dawn in the Middle Ages. By the 13th century, the first mechanical clocks appeared in European monasteries, driven by heavy weights and regulated by a verge escapement. These early towers rang bells to call monks to prayer, marking the canonical hours with a sound that could be heard across town. The clocks were massive, often housed in stone towers, and required constant winding by hand. Their existence marked a shift from natural to artificial measurement, allowing societies to coordinate activities beyond daylight. The invention of the escapement mechanism in the 14th century, credited to English and French clockmakers, dramatically improved accuracy by controlling the release of energy in regular intervals. This innovation made it possible to create smaller, portable timepieces such as the verge-regulated pocket watch. As trade routes expanded, these watches spread across Europe, becoming status symbols for merchants and nobles alike. The ability to carry personal timekeeping devices began to reshape daily routines and business practices. In the 16th century, Dutch scientist Christian Huygens introduced the pendulum clock, which reduced daily error to less than 15 seconds. By suspending a weight from a swinging pendulum, the clock achieved a regular beat that could be calibrated to the length of the pendulum. This breakthrough made precise timekeeping essential for navigation, as sailors could now determine longitude at sea with greater confidence. Huygens' design set the standard for public clocks throughout Europe for the next 2 centuries. Chapter 4. Precision and Standardization. The 18th century brought the marine chronometer, perfected by John Harrison after decades of experimentation. Harrison's sea-tested timepiece kept time within seconds over long voyages, allowing navigators to calculate longitude accurately using celestial observations. This invention transformed global trade, enabling safer and faster sea routes between continents. The chronometer's success demonstrated that precise timekeeping could have profound economic and geopolitical consequences. The expansion of railways in the 19th century created a new urgency for synchronized time. On 11 November 1883, North American railroads adopted a system of 5 standard time zones based on Greenwich Mean Time, a decision formalized at the General Time Convention in Chicago. This railroad time quickly spread worldwide, leading many nations to legislate standard time zones and daylight-saving practices. The coordination of schedules across vast distances became a cornerstone of modern industrial society. At the turn of the 20th century, the International Meridian Conference in Washington, D.C., in 1884 established the prime meridian at Greenwich, creating a universal reference for longitude and time. This agreement paved the way for the Greenwich Mean Time, GMT, standard, which would later evolve into Coordinated Universal Time, UTC. The adoption of a single global time reference facilitated international communication, telegraphy, and eventually radio broadcasting. Chapter 5: Atomic Age and Digital Revolution. The mid-20th century ushered in atomic timekeeping when physicists built the first cesium beam atomic clock in 1955 at the National Institute of Standards and Technology. By measuring the natural vibration frequency of cesium atoms, these clocks achieved an accuracy of better than 1 second in millions of years. Atomic time became the foundation for International Atomic Time, TAI, and later Coordinated Universal Time, UTC, providing the precision needed for satellite navigation and scientific research. Global Positioning System, GPS, satellites, launched in the 1970s, rely on atomic clocks to broadcast precise timing signals that allow receivers on Earth to calculate their exact position within meters. This technology transformed navigation for aviation, maritime travel, and everyday smartphones. The integration of atomic time into everyday devices made the concept of real-time ubiquitous, linking personal schedules to a universal clock. In the digital era, Internet time servers synchronize computers worldwide using the Network Time Protocol, NTP, ensuring that financial markets, scientific experiments, and social media platforms operate on a common timeline. Leap seconds are occasionally added to UTC to keep atomic time aligned with the Earth's irregular rotation, a reminder that even the most precise clocks must accommodate natural variation. This ongoing dialogue between human-made precision and celestial motion defines our contemporary relationship with time. Our journey from stone shadows to invisible atomic vibrations shows that time is both a measurement and a cultural construct, shaping societies from ancient temples to modern smartphones. Each breakthrough, sundials, mechanical gears, pendulums, railroads, and atoms, has expanded humanity's ability to coordinate, explore, and understand the universe. As we look ahead, the quest for ever finer precision continues, promising new ways to navigate both space and the fleeting moments of daily life. Stay with Historia for our next exploration, where we will trace the rise of money, its power to bind societies, and the ways it has reshaped human history.